Hello everyone, welcome back to my channel. I hope you are doing extremely well. So today we are going to solve one of the most important another problem from dynamic series, that is maximum sum of non-adjacent elements. So let's try to understand the question first. The question given an integer array nums of size n, return the maximum sum possible using the elements of nums such that no two elements taken are adjacent in nums. So what do it mean that? What do it mean that? Means we cannot take two adjacent element. See, 1 2 is adjacent, 2 4 is adjacent. So we cannot take and these adjacent together. Means we can take 1 or 4. Okay, or either we can take 1 as a single, or 2 as a single, or 4 as a single. So we cannot take 1 2 or 2 4. So this means adjacent. So let's try to understand the question completely with an example. So this is the example. 0th element, that is 1. Then I take 2th element, that is 16. Then I take 4th element, that is 4. That is 12. Firstly I take 0, then 16, then 12. So the answer would be 29, right? Means what I have chosen 0, then 2, then this. Okay, I think that would be the maximum. Let me check another way is that even we can take 1, means like 7 plus 4, that's it. Cannot take 12. Why? Because this will become adjacent. So what would be the answer? 11. Or I can take, see, 1 plus 4, that is 5. Or even we can take another way. Okay, but I think out of this all the maximum would be 29, right? So let's try to let us see another example which is given in the question as well. 1 7 16 8. So let's see the example. What would be the maximum result? So let's see. I can take either 0th element, or then 2th element. That's it. So the 0th element is 1 plus 16. That would be what? 17, right? Or I can take what? I can take like this is the one way, or we can take the first element, that is 7 plus I can even take like the third element that is 8. So what would be the max? What sum is 15? So out of 2, what is the maximum is 17. So here 17 is the answer. So if I have two options, that's if we are at the 0th index, then I have two options. Either I will take or I will not take. Either I will add that into my current sum or I will not add, right? I will not add. Even if we add, then we can go to the next step, that is the second index. But if we not add, then we can go to the first index, right? This goes here as well. I have two options in the second index as well. Either I will add that second index element in my current sum, or I will not add. I will just simply skip that and I will move to the third index. If I will add, then I will move to the 2 plus not 2 index, so that it should not be the adjacent. Same it will goes for all the index as well. So let's try to draw the recursive tree diagram for this. So let's try to draw recursive diagram. Okay, so let's see. So we pick we pick the 0th index. Let's be this is the array. So we pick we pick at the 0th index, we pick 0, and we move to the second index, right? So what would be there? See here, we pick the 0th index element and we move to the second index, right? Or I haven't picked the 0th element and I move to the, so I haven't picked and I move to the first index, right? From 2 as well, I will pick the, like I will pick the second index element and I will move to the fourth index, right? These all are index. These all are index, right? Or I haven't taken the second index, okay, and what I will do, I will simply move to the to the like a third index, right? Here also I have two options. Either I will pick that third index element to my current sum, or I will not pick that sum. If I will pick, then after picking I will move to the uh, third to fifth index. If I haven't picked that one, so I will move to the fourth index, right? From here, as fifth is the index out of bounds, so from here I will get the 0, right? Or if I will if I add the fourth index, so here from here this is the last cell, so here from here I will simply return 15, okay. So see what is the max, okay. So what is happening here, basically see, we just simply add 0th index value is 1, so 1 we pass here and 1 plus definitely 1 we have added here and we passed 16 here, 1 plus 16, that is 17 plus, right, 17 plus 4, 17 plus 4 is definitely 12. So this is the like answer, that is nothing but 29, from where I will read it 29, okay. If 29 from where I'm getting 29, if I'm I'm including from tooth, if I'm including the tooth element, okay. But if I'm not including the tooth element, then what is the answer? That is I get 1 plus from here 1. So if I will include the, then this gives me the, basically definitely if I will try to include in that one, then it gives me 1 plus 4 is 5, right? Or if I will not include that one, so what is the, like if I will not include that one, so here I will comes with 1 and 1 plus what is the fourth is 12, right? So 1 plus 12, that is nothing but 13. So if I will include this thing, so basically what is happening here, 1 plus 3, right? We are skipping this tooth index, so what is the value that we are getting 5. But here if I am skipping that 4 and if I am taking 1 plus 4, that is 13. So what is the maximum, either out of either 5 or 13? 13 is the maximum, right? So 13 is the maximum here. So from here I will simply return 13. That if I has not included the second index, so the maximum I'm getting 13. But if I am including it, then the maximum I'm getting is 29. So out from here, from second index, what is the maximum? 29. So from here I will simply return 29, right? So 29 is from where I am getting, if I am including the 0th index, right? If I am including the 0th index. But if I am not, then see what would be the value. So here I am like just passing 1, and yeah, either I have also two options. Sorry, let's take here. I'm here to 1. I have two options. Either I will contain this 1, so 7 plus I will reach to the second index, sorry, third index, right? Or I will just skip that one. It means no index. So I will move to the second index, right? So here I have two options as well. Either I will add this 7 plus, and the third index value is 4, that is 11, and I will move to the fifth index, okay. It's all the index. So fifth index, or I can simply skip that one, so 7 plus, that's it, simply skip that one and I will move to the fourth index. So from where, as it's out of bounds, so it gives me the 0, 4 plus 11 is 11. From here I am getting 11. From here I am taking the 11 data. Let's clear this thing. Yeah, I'm including that third index, then the maximum I'm getting is what? 11, right? But if I'm not including that one, then what is the maximum is 7 plus 12, that is definitely be 19. So out of 11 or 19, when we are getting 11, when we are including 3, when we are getting 19, when we are including fourth and we are skipping 3. So out of these, like 19 is the maximum. Let's try to here. I have skipped the 1 and I move to the second index. So what would be the like? So here also I have two options. Here as well I have two options. Either here also I have two options. Either I will pick two. So either I will pick that index, that is definitely 16 plus I will move to the 4, or I haven't picked and I move to the third index, right? So if we are at the fourth index, so what would be the value? That is definitely be 12. So 16 plus 12, that is 28. I am getting 28 from here. Or if I will add 3, so definitely, let's see, I have two options here as well. I will move to the, I will include that one, that is 4, plus I will move to the 5th index, that is definitely be index out of bounds, so it gives me the 0. Or I can move to the 4th index, that gives me 12. So out of 4 or 12, what is the maximum? Maximum is definitely be 12. So if I will not include that third index, so I will get 12. Or if I will include that one, then I'm getting the maximum 4. So out of 4 and 12, what is the maximum? Maximum is 12. So definitely from here I'm getting 12, right? But here from 20, from if I will include second index, so maximum I'm getting 28. But if I'm skipping that index, so I'm getting maximum 12. So out of 2, definitely 28 is the maximum value. So if I am skipping that 0th index, so I am getting the 28, and if I am including that 0th, then I am getting maximum 29. So out of this, 29 is the maximum, so this is our answer. So I am sure, and I am definitely be sure that this recursion tree helps you to understand the question properly. So it's not that much too much easy, but it just needs to be, just needs some a little bit understanding, that's it. So let's try to write down the pseudo code for this, that how can we are going to do it. So let's function that is in that I'm going to return the maximum sum, maximum possible sum. Then this is nothing but the array nums, and this is the like a current index. I can say index where I am currently now, or and this is the current sum, right? So let's see if I will check if index is greater than or equal to nums dot length, means that then in that case simply return the current sum. Or even I can also write down the best case if we reach the end. So like if we reach end, so we don't need to recalculate that. Simply if index equal to nums dot length minus 1, then simply return our current sum plus nums, then like a length, simple last index, that's nothing but index. Okay. If not, then what I will do, I will just firstly pick pick the current sum or not pick. So firstly I will call for picking, adding current value into my sum. So just call fun, then nums index plus 2, then current sum plus nums index. That's it. Show or not add, not add. So in that case I will simply call function then nums index plus 1 and we'll pass that current sum as it is. That's it. And whatever it will they gives me, yeah. So yes, so I will check I will take one add like yeah sub one pick not pick, and now simply I will simply here I will return max, max out of like both not pick or pick. So I hope this is the code which is completely language independent. You can write down this like logic into your own programming language. So let's comes to our code editor and like so definitely it will work and let's try to write down the code first. Okay, so calculate sum, so passing nums, then index, then current sum. I will firstly take one variable and nums dot length, length length. Yes, exceeded, c double ed exceeded, index array. Then simply like index so greater than or equal to none. Simply I will just return sum. Else otherwise simply I will also check if reach the last like index value, then just simply I don't need to then recalculate like a call and for another if index equal to n minus 1, then simply just add that last index value in current sum and then just return that one nums index got it. Check now call add like current value into current sum, your cal sum then nums then index plus 2 then current sum plus nums index math adding value not add sum nums then index plus 1 pass the current sum as it is. Yeah, that's it. And not adding value current sum. Simply from here simply I will return I hope that it will work perfectly fine. Let me call this function cal sum then nums then 0 then 0, right? Let me check once. Okay, it worked perfectly fine. So yeah, so let's see. So this is the recursive approach, and here if I will try to run, then it gives me the TLE, time limit exceeded. Why? Because the time complexity is very high. Because every time at every index we are calling the same twice. So the total time complexity would be order of 2 per power n. Okay, how can we optimize it? So if we see recursive recursion tree carefully, then we can analyze from here that see like we can analyze from here. See this three call twice, right? This two call twice. This three calls again twice. So means there are so many value which are repeatedly calling. Means we are recalculating the same value which we have done previously again and again. So due to this it taking lots of time. Okay. So how can we optimize it? Yes, when we have to calculate the same thing repeatedly, then in that case definitely memorization concept come. So definitely we will for the memorization we will DP, and we will store the every calculation value so that when we need the same value index value, then we will reuse that. Okay, so how can we do it? Definitely see. So just nothing, we don't have to do anything else. Can just we will modify a little bit from here. Okay, and we try to do it. So let's comes to the code editor. I am all to save the time. I have already written down the code for you as well. So this is the so I will try to explain each line one by one. So firstly I will slice the DP, then I filled with -1 so that I can differentiate that which value has calculated or which was not. Okay, and with -1, so I am calling this function, and again I'm checking the base case. Okay, after that if I'm checking here if this index value we have calculated again previously or not. If yes, have calculated previously, then simply return it. If not, then just calculate. Then I will just calling one by adding that thing. I'm just calling that one. Okay, and adding means including that current value in the sum, or I can simply not including it, and out of both what would be the maximum, either assigning into the DP, so that into that index, particular index, so that in the future if at the same index we came again, so we can tell that from this index that would be the maximum value that we can get. So yeah, this is the DP. So I hope if I talk about its time complexity for the DP, yeah, for the DP or DP, or we can say memorization, the time complexity would be order of n, and space complexity would be order of n, because we are taking extra space of to store the value, that is DP. Or we can say plus, this is the as we are using recursion, so it's taking the stat space, so order of at max order of n call would be there. So yeah, and on an average the space complexity order of n. Okay, so yeah, this is the optimized. Even we can also done the, as we have now done memorization, and in the next video I will tell you about the tabulation, how can we do through tabulation. So this video is going to be lengthy, so that I will tap that into separate video. So thank you so much for watching the video. I hope it helped you a lot, and I will come back with another important video for you. Till then, bye bye, take care.